Here we have the last set of examples from 4.7 part 1, and this is really where we get things kind of working together. This is about compositions of regular and inverse trig functions. So we are composing the two things together, which means that we're just putting them together in the same expression. You'll notice that in each one of these expressions we have a regular as well as an inverse trig function. Now, they might be in the different orders. You'll notice that this first one has the regular one first, inverse second. Now, these other ones have the inverses first. Now, that's important because the one that's first, the overall formula for this one is going to be the one that has the most effect on what comes out of it. So if it's a regular trig function, remember that what comes out of that is a ratio. If we're talking the inverse trig functions, what comes out of those are angles. So we can expect to see angles for these three and a ratio for this one, just familiar to us because we're using a lot of things having to do with the special right triangles as well as some quadrantal angles. Let's start with this one right here, where we have sine of tangent inverse of 1. Now, here's something that I'm going to ask you guys to do for all of these problems. It applies to everything, is evaluate the inside first. So let's forget about the sine inverse. Tangent inverse of 1, we're going to evaluate that first. And the thing about this one is that we've already done that. On a previous example, we did tangent inverse by noting that the tangent inverse of 1, it's hard to see the 1 there, but we noted that 1 is going to put us in quadrant 1. And then our triangle, we draw 45, 45, 90, so that is pi over 4. All right, so that means that this tangent inverse of 1 is going to be replaced by pi over 4. So I'm going to rewrite this as sine of pi over 4. Now, it's really important to me that you replace that you actually do a second step by rewriting this. If you jump right to the answer, I'm going to wonder what's going on with your problem here. Now, this one should have a picture with it, so I'm going to draw the picture over here. And it was a 45, 45, 90. So it was square root of 2 over 2. And 1 like that. So it was a 45 triangle. All right, so this one came from this picture. It was tangent inverse of 1. It was set up here in the first quadrant. It was a 45, so that's pi over 4 is where that was located. Now we're going to go do this as if it's a completely new problem. The nice thing is the picture is already there for us. This is pi over 4. That's our triangle that we need for it. And so now we can just say sine of pi over 4, which is this angle, is opposite over hypotenuse. And so that's going to be square root of 2 over 2. So what comes out of this one is a ratio, a fraction. The other three, those are all going to be angles that come out of them, but we'll keep going with this thing of drawing the pictures. Next thing is we've got here cosine inverse of cosine of 7 pi over 4. So we're going to do these things one at a time, like I mentioned, and cosine of 7 pi over 4, we need to set that up first. So let's just do that over here with this picture since we've got already a grid going. But 7 pi over 4, that happens to be the angle in the fourth quadrant, but it's also a 45 multiple. So this is going to be a 45 in here. It's still square root of 2 along here, but then this is negative square root of 2 over 2 along here, and that hypotenuse is 1. So what is the cosine of 7 pi over 4? Well, it is adjacent over hypotenuse. So in this case, replacing what's in here, we're going to rewrite this as cosine inverse of square root of 2 over 2 divided by 1, which is square root of 2 over 2. All right, so we get to that portion, and now we need to evaluate this one, kind of like what we're doing in the last example, that last video. And we need to get a picture with this one as well. Now I told you in the last video that when you're doing inverse trig functions, first of all decide on what quadrant is it in. Now cosine inverse can be either in 1 or 2. If it's positive, it's in 1. If it's negative, it's in 2. Clearly this one's positive. So what we have here is quadrant 1. So we'll just borrow from this picture up here so I don't have to redo the picture. If you've got a picture that goes towards several problems, you can do that and just make sure you point to the problem that you're on. Cosine inverse of square root of 2 over 2, just verifying that in this triangle, if we do adjacent over hypotenuse, is it square root of 2 over 2? Yeah, it is. So this is our location. We're going right here to find that very thing. This is going to be at pi over 4. And so now we get pi over 4 as the output to this one, which again makes sense because we have an inverse trig function. What should come out of that is an angle. All right. Just reiterating here the things that I'm looking for when you're doing these compositions. For one thing, drawing pictures with everyone, that's been the way it has been for the last few sections. But then also remember that I'm looking for you to rewrite this into one intermediate step before you jump to the answer. And we'll continue that pattern going forward in this one. Next one, number 3, is the arc cosine of tangent of pi over 4. All right, so again, we have an angle, or we have a piece here where we can actually borrow the picture from what's already on the page. So tangent of pi over 4. Well, this is that picture. And we can do opposite over adjacent. So tangent of pi over 4 is just equal to 1. Now, one other thing I want to address here is it says arc cosine. I don't necessarily like that notation. You might be okay with it. That's fine. But I'm just going to change this to what it also is, and that's cosine inverse. And so now we're looking at cosine inverse of 1. Now this is where people can start to scratch their heads a little bit, because we're looking at this and you say, okay, it's got to be an angle that comes out of there, but it's a ratio of 1. And in my special triangles, none of them have that 1. So just to illustrate that down here, if I've got a 45, 45, 90, square root of 2 over 2, square root of 2 over 2. And if I try to do adjacent over hypotenuse, that's not equal to 1. And even if I flipped it and I did adjacent over hypotenuse, that's not equal to 1. How about the other triangle? So the other one we've got is 30, 60. So we've got square root of 3 over 2, and we've got 1/2 and 1. So let's say that this were my angle. Well, then I would have 1/2 over 1. That doesn't work. Now I'll say that this was my angle, and I had square root of 3 over 2 divided by 1, adjacent over hypotenuse. That doesn't work either. So it's not either one of the special right triangles. This is where people get hung up a lot. So here's what it actually is. It's going to be one of our quadrantal angles. So if you've exhausted triangles and you just don't know where to go, try the angles on the quadrant, on the axes like these. So you'll notice that these points, we've made these before, where this is the point 1, 0, this is the point 0, 1, this is negative 1, 0, and this one is 0, negative 1. Now, also remember that cosine of a quadrantal angle, or of any angle, is the x value in the circle. So this is essentially saying, at what angle is the x value equal to 1? Well, of these 4, our choice is going to be right here. And so that angle, we could either call it that's at the start or at the end. Usually we label it by the start. And that is just in the position of the angle 0. Now I'm going to put 0 radians just to reiterate the fact that this is at that spot. You could put 0 degrees, but most of the time we don't use degrees in these problems. So 0 radians. That is the trickiest one to get a handle on in this case. If that one doesn't make a whole lot of sense, please make sure that you're asking me questions about that. All right. Moving forward here, though, I've got this picture now with the quadrantal angles, and that's actually kind of a good thing because this last example is one that uses this one more time. So we have tangent inverse of cosine of pi. All right, now pi, that angle is right here. That's at this spot. So the cosine of an angle is, again, its x value. So the x value at this spot is going to be -1. So now I have tangent inverse. I'm rewriting this. Tangent inverse of -1. So I've rewritten it. Now I just have one more step to find out what is the tangent inverse of -1. Here's where we go back to our method of figure out the quadrant, figure out the triangle, and then decide where it's placed. So tangent inverse, again, that's either quadrant 1 or 4. Since it's negative, that means we're dealing with quadrant 4. And now that we have its -1, that's going to be opposite over adjacent. So this must be the right placement for it because negative square root of 2 over 2 divided by square root of 2 over 2 is -1. And so that angle is what we're looking for. So we're thinking about what is that angle? Well, remember we have to back into the fourth quadrant. So you might be tempted to say 7 pi over 4, and you'd be close, but we're backing into that quadrant instead. So if you back in, you go -45, that's the same thing as negative pi over 4. And so that is compositions of inverse trig functions and regular trig functions. This is, pretty much the toughest stuff that we're going to be looking at all year. So if you understand this, you're in a great spot. If you don't, just make sure you're asking questions because we can get this figured out. And if you do, then you're ready to keep moving forward and you'll be in a good spot. This is challenging material. Thanks for sticking with me on this one, and keep watching in part 2 for more problems like this.